Och gott folk, är det dags att rikta blickarna mot Innodex Arena och Tech Arena här, scenen. Och om, ja, det är inte mer än bara 3 minuter, knappt lite dryga 3 minuter, så kommer vi få lyssna till Stora Enso och Otto, Kivi från Stora Enso, som kommer prata om hur batterier då batterimaterial kan komma ur trä. Så det är dags att bänka sig. Det är faktiskt så att de här bänkarna som är här framme, de är rätt bekväma. De ser kanske inte så bekväma ut, men de är väldigt sköna att sitta vid ändå. Och man kan passa på att göra det under tiden där det är föreläsning. Så ni är välkomna fram. Tack så mycket.
All right. Switching to English now with Otto Kivi from Stora Enso. Welcome, Otto.
Thank you.
Okay. So when I think about Stora Enso, I think about big industries, paper-ish, energy-ish, stuff like that. Am I in the right path here, or what are we doing?
You are, and you are not. So paper-ish, yes, we are exiting from the paper business, and we are doing, we all know what is happening at the paper demand at the moment, but what we are doing is we are finding new products out from trees. So the raw material is still the same, and we try to use less and less energy, and we try to produce less and less energy. We try to use the biomass better way than to burn it for the energy.
All right, interesting. Earlier on, when I asked you some questions, you told me about this innovative center in Nacka, Stockholm.
Yeah.
And we kind of said we don't think people know about that.
Yeah.
What is that with Stora Enso?
So basically, it's these processes when we are doing the innovation and the what we call like a front end innovation. They are long processes. So it doesn't necessarily fit in our day-to-day operations. So we have taken most of the innovation and the R&D, or not most, but big part of the R&D team into separate building. Try to build up like a startup kind of atmosphere. So it's our own startup facility. We call it Sikla, so I think the Nacka is the Hammarbystrad or something like that. Sorry, min svenska är dålig. So, but we have roughly 200 scientists working in the different innovation area, 25 different nationalities in Stockholm.
All right, and now we're going to talk about batteries and how to make them meet the challenge how to make them more sustainable, right?
Yes,
All
yes,
right.
we are going to talk about one component.
Go ahead.
Great,
Thank you.
thank you.
He turned it off. If you tell me what to say, do you think that will work? Yeah.
Okay, now the mic works again, so great, let's start. Hey, great to be here. Great to see that so many of you here, and great to see that one of our innovation generates interest. So my name is Otto Kivi, and I'm working in the business development for Stora Enso, focusing our bio-based anode material, what we call Lignode. And this is not changing the slide, so let's start it over then. Some technical challenges. Okay, good. Hey, we are in Sweden, so I think it's a little bit easier for me to give the presentation here in Sweden, because most of the people in here know what is Stora Enso. But Stora Enso, still we are one of the leading renewable materials company in the world, one of the oldest company, or actually the oldest publicly listed company in the world. First written record of our company is 1288. Started as a copper mine in close to Falun, so Stora Koppersberg. So we have done through a few business transformation during the roughly 750 years we have been in the operations. And what we are here, we are on the mission. So we are transforming fossil-based materials to renewable solutions. So we think that everything that is made from fossil-based materials today can be made from tree tomorrow. For some solutions it takes more time, and for some solutions we are already there. And while doing at this, we were just discussing, yes, we are already a big company from the Scandinavian size, not in the global scale, but last year we did roughly 12 billion euros turnover, so that's roughly 120 billion SEK, a little over 20,000 employees, global operations, really Scandinavian, Northern European centric, and we are listed in Stockholm and Helsinki Stock Exchange. But why we are here to talk about the sustainable anode material? I think we have all seen this, so we need to do something. The climate is changing, and we think that by making more products from the trees, it is actually helping against the climate change, because one thing is that the trees, they are our natural raw materials. They grow back and they fight. They help us to fight against the climate change, because they store the carbon. They reduce the carbon from the atmosphere, so they are taking the CO2 and store that in the trees throughout the photosynthesis. But they are only taking the CO2 when they grow. So that's also the important thing, is to always remember that when we are talking about the forests take CO2 when they grow, and the forests grow by volume the most in here in Scandinavia region when they are between 30 and 60 years. Also, we think that recycling is good, so we should always design our products so that they are recyclable, but it's not good enough. Also the source material should be bio-based, so it should be bio-based and recyclable. And yeah, most of our products, what we are here, in here today, I'm here to talk about how to replace graphite, but typically our main business today is packages, different packaging materials. So typically we are here to replace plastic. And talking a little bit about our raw material, most of our raw material is coming from Scandinavia. And all of the raw material, all of the wood we are using is coming from the sustainable sources. Almost 90% of it is coming from the, what we call semi-natural forest. So that means that they have been taken care of like by man. So they are not. They are not. So they have been used. So they are kind of like a semi-plantation here in Scandinavian area. Most of the wood we use is certified, so 80% of the wood we are using is either BEFC, so that's a Pan-European Forest Certification, or FSC, Forest Stewardship Council certified. And we are, as a company, we are quite big forest owner by ourselves, so we are having over 2 million hectares of the forest that we own or control. And 99% of our own forests are covered by certification. By this, we are, when we are looking at about this 2 million hectares of the forest, we are the world's second largest private forest owner. So basically, we can control the whole supply chain from the forest to the end product. And what we are doing here, like we were discussing, we are our innovation, what we call our innovation center, that's in Stockholm or in Nacka. So what we are doing, we are innovating, and we are always innovating with basically with trees, so with the renewable materials. We don't think that when one is talking about bio-based materials, you should use bio-based feedstock, which is not suitable for eating. So that's why we don't do any innovation with corn or with any agricultural waste, but we are typically using mainly trees. And how we are seeing the sustainable innovation, just a few examples. Sometimes it can be really easy, just by optimizing the packaging solution. So basically, if we are looking at if we are using okay, maybe you don't need to use the artificial intelligence for this, but when you are optimizing the packaging, 44% less material means 44% less CO2 emissions if the material is the same. But if you are changing the material, if you don't use the white carton, so the white carton is we need to use chemicals to whiten the carbon, so the LCA footprint of the white carton is always higher than the brown one. Same goes, this is a fluff pulp. Fluff pulp is used in the hygienic products. Easier example is children's diapers. They are all white, and there's a reason why they are white. But if we could think that we could use brown diapers, for example, the CO2 emission is 33% less if we would use brown pulp instead of white pulp. So this is also a change of mindset. We all need to do it. It's not always that the white is clean, yes, but it's not always the most environmental friendly thing. Construction. When we are replacing different concrete elements with wood-based elements, we can the LCA footprint is 70% less. So, and also the wood is storing the carbon, so the buildings are acting as a carbon sink. I think there was a presentation earlier this morning which was saying about this. So actually, if you use the biogenic carbon content stored in the trees, you can say that the CO2 footprint is negative. So they are actually storing quite a lot of the carbon. In here, there's one example of the packaging foam. You can see, you can go there afterwards. But this is to replace PE, so polyethylene foams in a different packaging when you are packing electronics. It's a 99.9% cellulose based. The LCA is roughly 75% lower than with the PE foam. Properties are almost the same. It's not the same product, but it can be used at the same way. And okay, yeah. And then it's not. Then the one that I'm here trying to spend the most time today is to talk about our bio-based anode material. And this is if we are looking at how we are doing it, just in principle. Half of the trees is water, and then the another half, of course, then that's a solid content. And to make it easy, about 1/3 of the solid content is cellulose, 1/3 is lignin, and 1/3 is hemicellulose. Cellulose is the fibers that's needed to make. In the past, cellulose was made needed to make paper. Today, mainly different kind of fiber-based packaging products. 1/3 is lignin. Lignin is a binder system of the trees. So without lignin, or lignin is not the lignin is a binder system of all the plants. But without lignin, for example, trees would look like spaghetti. So that's what are giving the strength and the stiffness for the fibers. And hemicellulose, that's the sugars. How we are utilizing these today? So basically, like I said, cellulose, fiber-based packaging, lignin and hemicellulose, we are burning those. Or we are not the only one. All the pulp makers are burning burning most of those to make a bio-based energy. Now the new pulp mills are much more energy efficient than in the past. So when we we can extract the lignin without affecting the energy balance of the pulp mill. Hopefully in the future we can extract all of the lignin and find alternative energy sources, the renewable energy sources to power the pulp mills. But today we can extract part of the lignin, and our IP is in the what we call, we are just in here saying the refining process. So when we are taking lignin and then we are having a different mechanical and thermal treatments to make it what we call Lignode, and Lignode is the active anode material for the lithium-ion and the sodium-ion battery cells. So, and why lignin? Lignin is the roughly, on average, if we are looking at the softwood, so softwood is pine and spruce, which is the two main tree species here in Scandinavia. Roughly 70% of the pine and spruce are lignin. Not lignin, but roughly 70% of the is carbon from the lignin. So that makes that lignin is the second most common carbon source in the globe, the most common being cellulose. But there is already a use for cellulose, so we chose lignin for this product. And when we are talking about anode, so anode is the negative side of the battery cells. Typical component is that on the positive side you have the cathode, and that's the different metals. Typically, so today you have heard lots about lithium, nickel, manganese, cobalt. Those are mixed to make the cathode, the positive side. In between there's a separator, typically PE film, and then the anode side, that's 100% graphite. So, and we are in here we can replace the graphite, so the whole negative side, with our bio-based carbon. It has a huge effect of the whole LCA of the battery, because it's the single biggest component, because the cathode was a mix and the anode is 100% one material. So it's roughly 30% roughly 40% of the volume of the battery, roughly 30% of the weight of the battery is in the anode side, so negative side, so it has the biggest impact on the LCA. And if we can make that locally, today roughly 90% of the active anode materials are made in China, brought in here. But if we can make it locally, we can cut the emissions from the supply chain. And also when we are using a bio-based, we can say that our anode would be storing carbon, so we can say that the CO2 footprint would be negative. If we are comparing to graphite, so basically in here, technically again, this is the case that like many of the sustainable innovations, it's not easy to replace one-to-one. So when we are having some benefits compared to graphite. So basically we can offer faster charge. With our Lignode, you can go up to 6C. That's a technical term saying that 6C means that you can charge your battery from 0 to full in 1/6 of the hour, so basically 10 minutes. That's in theory. And in graphite, the maximum theoretical limit is 2C, so from 0 to 100 in 30 minutes. That's a clear benefit in here in the Nordics. Then our anode is working better in the low temperatures. That's also, of course, a relative term. In Central Europe, the low temperature is, of course, totally different than in here. Cycling stability is better. Cycling stability equals longer life. So with our anode material, you can have a longer life. But of course, to be honest, it's not only the positive things. We are also losing a little bit on energy density, and energy density means how much energy you can put in the same volume of batteries. So basically, that means that you would need more batteries to have the similar energy when you are using our anode. But the clear benefits would be then the sustainability. And also, if the energy density, if we are looking at talking about EVs, energy density basically equals range. So how far you can travel with your car. But there's a possibility to mix the graphite and Lignode to make it the energy density the same and still get some technical benefits and also the better sustainability, and also at least it means that at least 50% of your battery anode material would come locally, so from Europe. And when we are comparing to this, so I mean the graphite in here, yeah, some of these things I talk about this a lot, so I mean the graphite is, I take it for granted, but there's two ways of making graphite to the batteries today. One is, which is more common, about 60% of the market is synthetic graphite. That's made from needle coke. Needle coke is a byproduct of oil refineries, and then 40% is natural graphite, and natural graphite means mines. There's, for example, there's a lot of discussions in the northern Sweden at the moment that should there be permits for the new graphite mines. Of course, the local people would not want those. I wouldn't want the mine in my backyard either, so I do understand people in that sense. But in here, so this is our innovation. It's not only an innovation, we are already on the pilot phase. Our pilot is located in Finland, in a town called Kotka, so that's on the south coast, 100 kilometers east from the Russian border. We are doing a joint development with the customers. I think in here you most likely have heard Northvolt. So we announced that in summer 22 that we are having a joint development agreement in place with them. Beyonder, that's a Norwegian battery startup. We are having a LOI in place with them. They are placed in Stavanger, and they are planning to build up the gigafactory close by. And then the latest addition, what we announced earlier this year, is that we are one of the partners with Polestar in their Project Zero. And the Project Zero is that Polestar is trying to create a commercial car without any GHG and without any offsetting by 2030. And we are partnering on the anode side, because when we are looking at the EVs and when we are looking at the CO2 value of the EV, one of the biggest contributor is basically there's a steel, there's aluminum, and there's a battery. And by the biggest component is the battery pack. And at the same time, we are doing the feasibility study for our first commercial Lignode plant. The location is not yet disclosed, but hopefully we can have some news soon. And then, you know, we are stock listed company, so I cannot really tell today more about timeline, except that 2030 is the year that we are saying that we are commercial by 2030. So, to sum up what we are doing here, so we are trying to be the most sustainable anode material in the world. We can offer local supply chains. So in here, of course, it's in Scandinavia. We can offer Scandinavian supply chain, but typically we are saying that this is from Europe to Europe. And performance, we think that already today we are having a high performance product. We are having quite a lot of data available, but that's since we are not commercial, we treat that as confidential. But we are we are convincing today the cell makers and automotive OEMs to partner with us on this. So basically, like I said in the beginning, we think that everything that is fossil-based today can be made from tree tomorrow. Any questions, please?
All right, thank you, Otto. I actually have a question.
Okay.
We talk a lot about, you mentioned a lot of possibilities with lignin and the innovative work that you do. How about the challenges? What would you say is the biggest challenge to come to a commercial product in 2030?
That's maybe there's two parts of that answer. The first one is, of course, can we scale this innovation so that we have enough volume at a reasonable cost, so we would have customers. That's one thing. And then the second one is that because we really want to scale this big, we are having 2 pulp mills in the Nordics, so one in Skutskär, close to Gävle, and one in what we call Enocell, so close to a town called Joensuu in Finland. The lignin, what we can extract from our own operation is not enough, so we need to work with our competitors to, in here, Södra, Billerud, Korsnäs, companies like that, and that's maybe not a traditional way of doing business. So.
All right.
But we need to do something together to save the environment.
Great. I love that you ended with that, because that was my next question of how about collaboration, but you already answered that question.
Yeah, we need to do it.
All right. So if people want to know more about this project that you're doing, please connect to Otto Kivi from Stora Enso. Thank you.
Great.
All right.
Thank you.
Okej, jag byter till svenska nu igen. Vi ska byta ämne lite grann, för nästa talare på scenen om 5 minuter ungefär är Magnus Bergman från VBN Components. De håller på med additiv tillverkning, stål och hållbarhet. Den kombon ska vi prata mer om.